Hi, my name is John Danko. I'm president of Danko Arlington. We're a unique company located in Baltimore, Maryland. We've been in business since 1920, and we make aluminum sand castings, industrial patterns, and machined cast components. We're unique because Danko Arlington sells to military and commercial customers. We're strictly in the sand process right now, and we are using FDM printing for a variety of applications in our company. Danko Arlington chose to enter into additive manufacturing because there's a scarcity of pattern makers today. So pattern makers are the tool and die makers, the trade that makes the tooling for the foundry. And today that's a very, very scarce talent. So we were using CNC machining to make up the difference, but even today CNC pattern makers and CNC machinists are scarce. So we are now embracing additive manufacturing with machines made by Stratasys to fill that gap. At Danko Arlington, we have small volume, high quality production, and that's where FDM comes in. We are able to make patterns for small quantities out of ABS or PC10 plastic and incorporate them into small runs from anywhere from 1 to 100 pieces. In using FDM printing for pattern making, you don't have to worry about a rotating cutter. So what you can envision in CAD is what you can print. So you can print, for example, square corners, fillets, locating pins, backdraft, and even odd parting lines.
We can make a loose pattern, try out our gating, decide which side we want up, which side we want down before we invest a big investment in a mounted pattern. Traditional pattern making takes a lot longer. I mean, jobs that take months, we can make in a matter of a couple of days.
The FDM process is extremely accurate. Our sand casting tolerances are generally plus or minus a 32nd. Sometimes we go to plus or minus 20. The printer prints anywhere from 3 to 5 thousandths of accuracy, so we're already a fraction of what our tolerances are. So if we make a tool, for example, that's closer to size and nominal, then that leaves a lot more leeway in our process to have a better casting. We're also using FDM to make drill bushing fixtures, straightening fixtures, and check fixtures. So we can take the CAD that we have made for the casting and we can superimpose another design on top of that to make a check fixture, for example, for core setting or for straightening, and even to drill holes in castings after they've been machined. So it's a great time saver and also is very accurate as well.
Usually when we first get a job, we have to quote film cost on it because that's part of our expenses. And I typically will work from a two-dimensional drawing or blueprint. And it's sometimes hard to visualize thicknesses or positioning of the part when we do various X-ray views. Having a 3D model that's printed for us, we can actually mock up our real shooting just as if we had the actual aluminum casting, and I can estimate better where the camera angles are going to be, sizes of my film, number of parts on a film, and that helps me get a more accurate cost, which helps us get a better price in the end.
The unique thing about FDM printing is that you don't have to be trained formally as a pattern maker. You can be a draftsman or CAD engineer, and you can make patterns from what you see and what you draw on CAD-CAM. One CAD-CAM engineer can do the work of 5 or 10 pattern makers. And with 2 FDM printers, we're pretty much doing the same kind of work that we did 15, 20 years ago with 15 pattern makers. The FDM process has enabled our foundry to meet shorter lead times and make castings faster. We're able to print patterns in a matter of days or even hours as compared to weeks or months.